This is a tutorial video for GCSE Physics looking at power calculations in the electricity topic. By the end of this video, you should be able to define power and state its units. You should be able to calculate power from the current and potential difference, or calculate power from current and resistance. Then you should be able to calculate the energy transferred based on the power of an appliance. There are two different definitions of power in GCSE Physics. Either the rate at which energy is transferred or the rate at which work is done. Rate means speed, so when we think about an electrical appliance with a high power rating, it's able to transfer a lot of energy electrically very quickly, whereas a low power rating appliance transfers energy electrically more slowly. Power is measured in watts, and you'll see this on different appliances in your home if you look for the label with the power rating. The more energy an appliance transfers each second, the higher the power rating. And the highest power ratings tend to be for appliances that transfer energy by heating, like a kettle or an iron. When thinking about electrical power, there are several different equations that we need to use. The first of these is equation number 17 on physics equation sheet 1. Power is current multiplied by potential difference, or in shorthand, P is I times V. Of course, you need to know the units for each one of these components. So power is measured in watts, current is measured in amperes or amps, and potential difference is measured in volts. We can use this first equation by looking at a circuit in which we're given the potential difference and the current. So for instance here, I have a current of 0.5 amps flowing in a circuit where the potential difference is 12 volts. So power is current times potential difference, therefore power is 0.5 times 12, which gives me an answer of 6, and the units of course are watts. Here's another example of the same type. P equals I times V, so 3 times 6, which is 18 watts. Here's an opportunity for you to practice 5 calculations with this first equation. Pause the video, and once you've calculated the power for each circuit, unpause and check your answers. When a lamp with a 12 volt potential difference is supplied with a 3 amp current, the power will be 3 times 12, which is 36 watts. For question 2, you should have an answer of 13 times 4.5, which gives you 58.5 watts, and then 18 watts, 10 watts, and finally 2 watts. How did you get on? As we said, there are multiple different equations related to power on the GCSE Physics equation sheet, but if you're good at substituting and rearranging, then the truth is you don't need to memorise every single one because they can be derived from each other. We've just met equation 17, P equals I times V, and in the previous video about potential difference, we learned that V is I times R. So if we substitute in I times R wherever we find V, then we're left with P is I times R. And if we simplify that, then we get power is current squared times by resistance. This is equation number 18 that you're supposed to memorise, but as you can see, if you know the previous two, you can figure it out. The one thing we should mention, of course, is that resistance is measured in ohms. This question looks quite similar to the ones that we were just doing, but this time, instead of being given the potential difference, I've been given the resistance. So now I need to use this second version of the equation, P equals I² times R. So the power here is going to be 2 squared times 3, which is 12 watts. Actually, if I can remember the previous two equations, I can check my working. So originally we were using P equals I times V, and I know that V is I times R. So I can work out the reading on this voltmeter here by doing 2 times 3. So 2 times 3 is 6 volts, and so if I go back to my original equation, I'd now be doing 2 amps times 6 volts, which still gives me an answer of 12 watts. Here's a second example of the same type. So here, to calculate the power, I'm going to use I² times R, so 3 squared times 6, which is 54 watts. Here are 5 more questions of this second type for you to have a go at. Remember, this time round you're using the equation P equals I² times R. Pause the video, and when you're ready to check your answers, you can unpause. The power rating of a 2 ohm lamp in a series circuit supplied with a 3 amp current is going to be 3 squared times 2, which is 18 watts. A 0.5 ohm lamp in a series circuit supplied with a 13 amp current is going to have a power of 13 squared times 0.5, which is 84.5 watts. For question 3, you should have 75 watts. For question 4, 144 watts. And for question 5, 18 watts. During the energy topic, you met equation number 10 from the I can use this equation to calculate the amount of energy transferred by an appliance. In 45 seconds, a 1600 watt iron will transfer 72,000 joules of energy. Now pause the video and calculate the energy transferred by each of the remaining 5 appliances. Remember, each of your times needs to be in seconds, so if it's not already, you'll need to convert it. In 60 seconds, an 800 watt toaster will transfer 48,000 joules of energy. In 5 minutes, that needs converting to be seconds, so 300 seconds, a 3000 watt kettle transfers 900,000 joules. 3 minutes and 30 seconds is 210 seconds, and in that time a 900 watt microwave will transfer 189,000 joules of energy. A 1050 watt dishwasher can transfer 945,000 joules of energy, and 2 hours is 7,200 seconds. And in that time, a 150 watt freezer will transfer 1,080,000 joules of energy. I can put these equations together in extended calculations even when I haven't been told the power rating of a particular appliance. Here we have a 2 ohm bulb which is in a series circuit where a 4 amp current is flowing. I can use those 2 pieces of information to work out the power rating of the bulb. Power is current squared times resistance, so 4 squared times 2, which gives a power rating of 32 watts. Then I can take this time of 2 minutes and convert that into seconds, so 120 seconds, and I can use that together when I know that energy is power times time, so 32 watts times 120 seconds tells me that 3,840 joules of energy are transferred by that light bulb. Here's another question of the same type, so pause the video and see if you can calculate how much energy is transferred by this bulb. The bulb has a resistance of 5 ohms, and the current in the series circuit is 0.5 amps. So firstly, we calculate the power. 0.5 squared multiplied by 5 is 1.25 watts. Then we need to multiply this by the time. 5 minutes, of course, will be 300 seconds because we need to multiply by 60. 1.25 times 300 gives me 375 joules of energy transferred. Thank you very much for watching, and I hope you found this a useful introduction to calculations of electrical power. If you did find it useful, then don't forget to like and subscribe for more GCSE Physics videos coming soon.